All right, so we're closing down the gap till we get to the end of chapter 6, and we are at pretty much the last section, 6.5, which is all word problems. You're going to have word problems from completing the square. You're going to have word problems from factoring and also from quadratic formula, and these are the sections that they come from. Now, the question is, how do we know when we're supposed to complete the square, and how do we know when we're supposed to factor or do the quadratic formula? This tutorial is all about how to know when to do the pink and how to know when to do the purple. So you're going to do the pink when you are looking for the vertex. In other words, the question mentioned that you want to find the max or the min. If the question did not mention anything about a max or min, most likely they want you to find the x-intercepts, and then you'll have to factor or do the quadratic formula. All right, what I've done is I've included 3 different examples in this tutorial of word problems and also their full solutions. Now, I've included the full solutions so that it would just save on time. Okay, so here's a popular area question. I've categorized these into area question, number question, and then also Pythagorean theorem types of questions. Okay. Is it possible to enclose all 4 sides of a rectangular photo with an area of 150 centimeters using only 60 centimeters of framing? And if so, give the dimensions of the photo. They didn't mention a maximum or minimum anywhere, which leads me to believe that this is a question from 6.2 or 6.4. That means that I can actually solve this by using factoring or quadratic formula. It's really my choice. But before all that, I really need a formula first. So that's why I drew this diagram. I have my photo. I'm going to make sure that one side equals to x, which means that the other side should be the exact same length. And in order to find this one, this is the part where it's kind of confusing, we're going to take the entire perimeter, and that was the 60 centimeters. We're going to subtract both the shorter sides, that's where the minus 2x comes from, and that gives us the 2 longer sides. Now, I don't want both longer sides, I only want the one longer side. So I'm going to split it in half. This fraction looks a little bit ugly. I'm going to just simplify it. 60 over 2 is 30. 2 over 2 is 1. So I get my x by itself. Okay. Now that I have my length and my width, I can use these in an area formula. And I know to use the area formula because they gave us that piece of information right there. Area is your length times your width. So here is my formula right here. Okay, now this is probably the most difficult part of all of 6.5, creating these formulas. There's always some hints in the question itself, but it can be kind of tricky. Now we know that we have to solve by factoring or quadratic formula, and to do that, your equation has to be in standard form, which means that one side has to equal to 0. Okay, once it's in standard form, you can then do the quadratic formula or factoring. Now this isn't a tutorial on quadratic formula. I've already made a quadratic formula tutorial, so I'm just going to skip ahead. I decided to do quadratic formula, and I got 6.4 and 23.7 as my answers. I'm thinking that I probably made a really good choice doing the quadratic formula because I got these decimals. There's no way I would have guessed that through factoring. Okay, so the root 300 is what gave me this decimal, and it's an approximate number. So we need to make sure we remember our approximation signs, and that approximation sign carries out for the rest of the solution. Okay, now let's understand our answers just a little bit. We have one answer. So the first case is, what if x was 6.4? Then we can just solve the length by putting 6.4 into the x, and that gives us a grand total of 23.6. All right, so our length and width, oops, or our dimensions for one case is 6.4 and 23.6. If x ends up to be something else, 23.7, then again, we have to find its matching side, And in the end, we get our length and width. So you're going to have two different answers for the dimensions, but as you'll notice, they are very similar. Let's try another one. Okay, here's a number question. Find two numbers whose difference are 13 and whose squares, when added together, yield a minimum. Oh, minimum. Okay, that's a special word right there. That tells me right away that I'm looking for a vertex. I'm probably going to have to complete the square. All right, well, I need the equation first. And let's just think about it for a sec. Two numbers. So I got x and y. We'll just say those are my two numbers. And if x is the bigger one, I'm going to subtract it to get my difference of 13. Then I'm going to solve for one of the letters. The reason why I do this is once I have the equation right here, and I'll tell you how I got it in a second, I don't want more than one letter. It's going to be hard for me to solve. So I need to make sure that I solve for one of the letters, and then I can input it in as the other letter. Okay? Going back, let's figure out how I got this equation in the first place. Whose squares, so there are your squares, when added together, so I'm going to add them together, yield a minimum. We need to be able to complete the square to find that minimum. Okay, and again, has to be in standard form. So I'm going to go through expansion and simplifying just to get the standard form. Then I can complete the square. So I'm completing. Okay, I'm done. Completed the square. That's my vertex form. Okay, the minimum is right here. And it's not a minimum because it's a negative 84.5. It's actually a minimum because your a value is a positive number, which means your vertex points upwards. That vertex is a minimum. Okay, and this happens when your y value is the opposite of this positive 6.5, negative 6.5. That means that you've now found one of the numbers. To find the other number, you know that x equals to 13 plus y, and you just figured this out. It was negative 6.5. So you can easily figure out what y equals to. And then you have both the numbers. So the two numbers, 6.5 and negative 6.5, give you a minimum of negative 84.5. Okay, let's try one last one. Here's the last question, Pythagorean Theorem. One leg of a right triangle, so I have a 90-degree triangle at the left-hand side, is 1 centimeter longer than the other leg. Okay, so here's that first leg, and we're going to have a 1 centimeter longer leg. The leg of the hypotenuse is 9 centimeters greater than that of the shorter leg. Okay, so this one's the hypotenuse, and notice that it's 9 centimeters longer than the x. You want to find the lengths of the three sides. So they want all of these three. Again, they did not mention max or min. Therefore, right away, I know I'm doing factoring. Sorry, factoring is 6.2. Or I'm doing quadratic formula. And since I did quadratic formula last time, I'm just going to try to do factoring this time. All right, and we need an equation. I'm never going to say, hey, this is a Pythagorean theorem type of question. Why don't you use Pythagorean theorem? You should know that you're going to use Pythagorean theorem because you have the right angled triangle. That is a major equation that we use when we have right angled triangles. A squared plus b squared equals c squared. Okay? So your a squared and your b squared, those are just your shorter side squared, and then your longest side squared is your c squared. And again, you want to put everything into standard form. Well, maybe we should point it to the most simplified, so it's standard form, before we actually start factoring or doing the quadratic formula. So easily I can see, well, two numbers that multiply to negative 80, they add to negative 16. That's just positive 4 and negative 20. If you didn't know what the numbers were and you didn't want to guess, again, you could always do quadratic formula instead, and they would still give you these two numbers. Okay, now you'll notice that one of them was crossed off, and that's because there's no such thing as a side length of -4. That is called inadmissible. It's an inadmissible answer. So we know for sure that our actual answer is the 20 centimeters. And there you go. X is 20. Once X is 20, your other two sides can be easily solved as well. Okay, so the lengths are 20 centimeters, 21 centimeters, and 29 centimeters. So I'm hoping that this tutorial is helpful to help you figure out what to do when you have certain word problems. Again, just to wrap up, you want to make sure when it asks for a maximum or a minimum, you're doing completing the square. When it's asking you for anything else that doesn't have a max or min, you're probably doing factoring and quadratic formula.